For this question, we want to find the intercepts of the graph of the function without graphing the function. Our function is f of x equals square root x plus 27 minus square root x minus 3. I want to find the x-intercepts. And to find the x-intercept, you let y equal 0. Now this equation is written in function notation. So this f of x is the y. F of x is the same thing as y, so we're going to substitute a 0 in for the f of x. We have 0 equals the square root of x plus 27 minus the square root of x minus 3. So this is what we call a radical equation, and it's a pretty messy radical equation because it has two radicals in it. So the process for solving these types of radical equations is to try to eliminate the radicals. And the way you eliminate the radical is that you isolate it and then do the opposite to get rid of it. So we got to isolate a radical, and the opposite of this, these are square roots, so the opposite of this is to square. But the problem is that you can only do one at a time. So we're going to have to go through this process a couple times to eliminate the radicals, and then once we eliminate the radicals, then you can actually solve the equation. So we're going to start by isolating this radical here. And I first want to add it to both sides, so that it'll be isolated on the left. And once you have it isolated, then you're going to square both sides to get rid of it. I'm going to square the left and square the right. On the left, the square and the square root are opposites, and so they cancel each other out, leaving you with x. But on the right, this will get a little bit messy. When we square something, we multiply that base twice. So we're going to multiply square root of x plus 27 minus 3 times square root of x plus 27 minus 3. So we want to multiply this out. We'll multiply the first two terms together, then we'll multiply the outside two terms, then we'll multiply the inside two terms, then we'll multiply the last two terms. So we multiply square root of x plus 27 times square root of x plus 27 minus 3 square root of x plus 27 minus 3 square root of x plus 27 and plus 9. Now let's simplify. When we multiply these two together, they both have radicals, and the rule that we follow is that we multiply what's underneath them. So we can write this as square root of x plus 27 times x plus 27. So when you're multiplying the same square roots, you can multiply what's underneath them. Then with these two terms, they're considered to be like radicals. You notice that the radical part is the same, and when the radical part's the same, you can treat them like terms by adding their coefficients together. So these coefficients are -3 and -3. We add those together to get -6, and they had the same radical, so we keep it. And then I'll just carry down that plus 9. So then the next thing I want to do to simplify is I've got square root of x plus 27 times x plus 27. That's the same thing as x plus 27 squared underneath that radical. And just like we've seen before, the square root and the square are opposite operations, so they cancel each other out. So this is going to give me x plus 27 minus 6 square root of x plus 27 plus 9. So we've accomplished our first goal, which was to eliminate this radical. But as you can see, we still have a radical in the equation. So now we have to repeat that process over again. We now have to isolate this radical and then square both sides to get rid of it. Before we do that, let's do a little bit of cleaning up. We have some like terms we can combine together. So we have x plus 36 minus 6 square root of x plus 27. And I'm going to start isolating this radical by subtracting x on both sides. And that gives me 0 equals 36 minus 6 square root of x plus 27. I'm going to subtract 36 on both sides. That's negative 36 equals negative 6 square root of x plus 27. And then I'm going to divide by negative 6 on both sides. And I have square root of x plus 27 equals 6. So now I've isolated that radical. And we're going to get rid of it by squaring both sides. Those are opposite operations. So 6 squared is 36. The square root and the square cancel each other out, leaving me with x plus 27. And now I can solve the equation that's left. Now that all the radicals are gone, I see that this is just a linear equation. I want to get x by itself. I subtract 27 on both sides, and x equals 9. With the radical equations, you do have to check your work. Under normal circumstances, checking is sort of an optional step just to be sure that you didn't make any mistakes. But because of this technique that we're using to get rid of the radical of squaring both sides, sometimes this can cause you to have what we call extraneous solutions, extra solutions that don't work in the original equation. So anytime you use squaring both sides as a method for solving, you do have to check your work. So let me zoom out here. We want to go back to our original equation. Our original equation is when we substituted that 0 in. So that was right here. So our original equation is 0 equals square root of x plus 27 minus square root of x minus 3. And I want to check to see if x equals 9 is a solution to this equation. So I'll substitute that in. That's 0 equals square root of 9 plus 27 minus square root of 9 minus 3. 9 plus 27 is 36. Square root of 36 is 6. Square root of 9 is 3. 6 minus 3 is 0. So that solution does check out. And 9 is the x-intercept. We could write that as an ordered pair. On this question, we want to find the x-intercepts and y-intercept of the function. I like to start with a y-intercept because it's a little bit easier. And when we find a y-intercept, we're going to let x equal 0. So I'm going to substitute a 0 into the function that we have. Our function is f of x equals 3x squared minus 8x minus 9. We're substituting a 0 in for x. We'll follow order of operations. 0 squared is 0, and then multiply by 3. 8 times 0 is 0. 3 times 0 is 0. And we get negative 9. So we have a y-intercept of negative 9. So then we want to find the x-intercept by letting y equal 0. This equation is written in function notation, so this f of x is the same thing as y. So our equation becomes 0 equals 3x squared minus 8x minus 9. This is a quadratic equation because it has a squared here. And we have several different methods that we can use for solving quadratic equations. So let me write those methods down. We could solve this by factoring. We can solve it by the square root method. We could solve it with completing the square. Or we could solve it with the quadratic formula. So the four methods work in different ways. Some of them you can use all the time. Completing the square can be used on any quadratic. The quadratic formula can be used on any quadratic equation. So those are ones that you could use anytime. However, the completing the square method is very detailed and there's a lot of steps to it. And the quadratic formula has a little bit messy formula for you to memorize if you want to use it, and then also quite a bit of steps to simplify it. So we don't go to these methods typically first because of their answers being a little messier, their process being a little bit detailed. We typically try to do these other methods of factoring and the square root method first because the answers can come out cleaner and faster. So I typically start with factoring. This example, I would not be able to use the square root method, and the reason being is because this middle term is here. You can only use the square root method when that middle term is missing. So I'm going to start by trying to factor, and if I'm not able to factor, then I typically go and try the quadratic formula next. So let's start with factoring. When I factor, I use a technique called trial and error or guess and check. And so I set up two parentheses here, and these two terms in the binomial need to multiply to be the first term, and these two terms in the binomial need to multiply to be the last term. So I want to come up with what my choices are. So for the first term, I need factors of 3x squared. So that could be 3x and x. That's the only pair of factors that will work. And then for the end values, I need factors of 9. So factors of 9 could be 9 times 1 or 3 times 3. These are my only choices. So if I try every combination of this, I'm going to see if I have a factorization that will work. So I'll try 3x and x, and so this is my only choice, so I had to try that. Let's try 9 and 1. So we'll do 9 and 1, and I'm going to check to see if I get the right middle number. So the middle part comes from multiplying 9 times x and 3x times 1. If I add those together, 9 plus 3 would give me 12, and I want a middle number of negative 8. So that's the wrong number. It might also be subtracting these two. 9x minus 3x would be 6x. That doesn't match the middle number either. So this is not the correct factorization. So let me get rid of this. And we need to try something else. So remember, I called this trial and error. So I'm going to switch that 9 and 1. I'll put the 9 here and the 1 here. Try the inside and the outside. That's a 1x and a 27x. If I add 27 and 1, I don't get 8. If I subtract 27 and 1, I don't get 8. So this doesn't work either. So that means this pair doesn't work, and we can move on to another choice. So let's try 3 and 3. If I put a 3 and 3, we get 3x when we multiply the inside and 9x when we multiply the outside. 3 and 9 will not add or subtract to be a negative 8. So this doesn't work. Then we can switch them, but you'll notice if we switch them, it's the same thing again. So what we've concluded now is that this quadratic is not factorable. So I have to move on to one of these more complicated methods. And like I said, I'm going to use the quadratic formula. So let's get rid of my factoring attempt. And I'm going to use the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I need to use a x squared plus bx plus c equals 0. A is the coefficient of the squared term, b is the coefficient of the x term, and c is the constant. So for the equation that we have, a will be 3, b is negative 8, and c is negative 9. So we're going to substitute those values into the formula. That's going to give me x equals negative b. So I've got a negative in the formula, and b is also negative. Plus and minus square root of negative 8 squared, that's b squared, minus 4 times a times c, all over 2 times a. Then we're going to use arithmetic to simplify. We're going to make sure we follow order of operations. A negative times a negative would be a positive 8. Negative 8 squared is 64. This is a very common place where people mess up the quadratic formula. If you type negative 8 squared in your calculator and don't put any parentheses, you're going to get a negative number here. You need to put parentheses around it so that you get a positive. So this part is always positive or 0. So we'll continue. Then we have 4 times 3 times 9. Which is 108. And we have a negative times a negative. That's a positive 108. 2 times 3 is 6. Underneath the radical, you would need to add 64 and 108 to get 172. And then we want to try to simplify that radical. So let's think about factors of 172. That's 2 times 86. And maybe we can go a little bit faster here, because really what we're looking for is a perfect square. So let's focus only on the perfect squares. So our perfect squares are 4 and 9 and 16 and 25. That's 2 squared, 3 squared, 4 squared. I said 27, but that's not right. That should be 25. 5 squared. Okay, so let's focus on those perfect squares. So 172 divided by 4, that's 4 times 43. And I think 43 is prime, so that is going to work for us. Let me just try one more. 172 divided by 9 doesn't work. 172 divided by 16 doesn't work. And definitely we want to use this one here, 4 times 43. We'll do 8 plus or minus square root of 4 times 43 over 6. The square root of 4 is 2. The 43 stays inside. And then what we do, this is a fraction, and we always want to write fractions in lowest terms. So they shouldn't have any common factors. So if we look at these three numbers here, all three of these numbers are even, which means they have a common factor of 2. So we want to reduce this. 2 goes into 8 4 times, 2 goes into 2 1 time, 2 goes into 6 3 times. So we can write this as 4 plus or minus the square root of 43 over 3. You'll notice that I didn't write this 1. This is 1 times square root of 43, and so we don't need to write that 1. So this would be our x-intercepts for plus square root of 43 over 3 and for minus square root of 43 over 3. Thank you for checking out my videos. Have a great day.